x plus 3, x minus 3. The top is just x plus 3, and the bottom I can take an x and a 3x minus 1 out. If I'm just taking NPVs, I don't actually have to flip it and do all that stuff. I actually don't even have to simplify the top left. So my NPVs are everything but the top left when it's division. So x plus 3 cannot equal 0. X minus 3 cannot equal 0. X plus 3 again, but I don't have to write it twice. X cannot equal 0. Sit. Goodness. 0, and then 3x minus 1 cannot equal 0. Okay, quiet. So we have x cannot equal negative 3. X cannot equal 3. 0. 3x cannot equal 1. And then divide by 3. This is the one that people get wrong. X cannot equal a third. So our NPVs are x cannot equal plus or minus 3, 0, and 1/3. Number 2. It says simplify and state the restrictions. State restrictions is the same as non-permissible values. So the top, it's just a simplifying one. I get 2 minus x, 2 plus x. The bottom, I can take a 4 out. And I'm left with x squared minus 2. Can I do anything to that?
No.
Nope. 4 doesn't get me an NPV. 4 cannot equal 0. X squared minus 2 cannot equal 0. X squared cannot equal 2. And then I square root it. When I take the square root, I have to remember to do plus or minus. So I get x cannot equal plus or minus root 2. I have to be able to do those ones as well. So that's my only NPV. And this is simplified. Can't make it any more simple. For B, it's a monomial over a monomial, and then times a monomial over a monomial. Monomial means they don't have any plus or minus signs. So you're going to put every single thing in B in brackets. You can't simplify it. You're just going to put it in brackets. When I have a bracket touching a bracket, that's the same as what? Multiplication. So I have 16xy, 15m squared n. M squared I could just write as 2m. Times 5m and n 4 x. Oh, there is. Okay, when I have x's and y's by themselves like that, the NPVs for them are just can't equal 0, right? So I have m, n, x, and y cannot equal 0. I can just write it like that. You could write each one separately. M cannot equal 0, n cannot equal 0, x cannot equal 0, y cannot equal 0. Or you can go m, n, x, y cannot equal 0. X crosses off 1x, the m crosses off 1m, n crosses off 1n, y crosses off 1y. And you can take out of 5 and 15 and 16 and 4, right? But say you don't spot that. What's 16 times 5? Did anyone do it that way? 80? 80n squared over 15 times 4, which is 60, m x squared y. And then I can just go 80 divided by 60 and reduce it with my calculator, and I'm going to get 4 over 3. 4n squared, 3m x squared y, m n x y cannot equal 0. The last one here, when you have a fraction over a fraction, what does that mean? You're dividing it. If we ever stack fractions, rewrite them with the division sign in the middle. Don't ever leave them stacked. So we're going to go 20x minus 12 over x minus 3 divided by 5x minus 3 over 2x squared minus 18. You can, yeah. And just as long as you turn it to a multiplication symbol. So we can take a 4 out of the top, and we're left with 5x minus 3 over x minus 3. There's nothing I can do. I'm going to flip this at once and simplify. So the 2x squared minus 18 is going to move to the top. So I'm going to take a 2 out, and I'm going to be left with x squared minus 9. And then the 5x minus 3 moves to the bottom. And what's x squared minus 9 actually? Yeah, x minus 3x plus 3. Over 5x minus 3. Bless you. When I have a full, everything simplified, I can make it as a full fraction, right? And I have to state non-permissible values for everything but the top left because it was a division. So you have to watch yourself when you make it be a multiplication. People will sometimes forget that it was a division and not state all the right ones. You still have a question?
So like, would the bottom one, like in the fraction, always be on the right?
Yes.
How do you know it's on the left?
Yeah.
Like it's on the left.
Because this means this divided by, this is a division symbol. That.
Okay, well, nice.
So like if you have 7 over 9, if you have 7 over 9 as a fraction, that's 7 divided by 9.
Okay, yeah, I'm just making.
Okay, before we cancel, we must state non-permissible values. I know in here it didn't matter, so if you didn't state them, you'd be fine. But we would have x minus 3 cannot equal 0, x plus 3 cannot equal 0 because of the top right, and 5x minus 3 cannot equal 0. This one's going to be x cannot equal 3. This one's going to be x cannot equal negative 3. So I'm going to add my 3 over, so I'm going to get 5x cannot equal 3, and then I'm going to divide by 5. Now, if you didn't state NPVs for this one, it would be okay because it's a numeric response, right? I didn't ask for that. What cancels off? Well, we get 5x minus 3, 5x minus 3, x minus 3, x minus 3. And people will tell me I have 8x plus 3 left over, correct? Okay. So people will tell me the answer is 11. It's not. Because this has to be in the form ax plus b. Does that one have a bracket? No. So I actually have to do one step and distribute first so that it's in that form. So it's actually 8x plus 24. So it's going to be 24 plus 8, which is 32. Yeah. Yeah. Yes. Okay. What I want you to do in the meantime is get out your notes. The ones I handed out to you, the adding and subtracting. Yeah, I'm just waiting for them to. So take out your adding and subtracting. So our rule when we add and subtract, so when we multiplied, divided, simplified, we did all the same steps, correct? We reduced the top, we reduced the bottom, we reduced the top, we reduced the bottom. We stayed NPVs for the denominator except for divisions. There's denominator and the top right. But we did all the same steps. Then we got to addition and subtraction, and all we have left after this is solving, and we're done the rational unit, just so you know. So, and equivalence a little bit, but with addition and subtraction, what was our top priority in order to do addition and subtraction? We need a common denominator. So let's look at 3y and 5. This throws people off. So the 3 and the y, are they attached? No. No. So the first thing I would do is I would have 1 over 3 and y in its own brackets plus 6 over 5 in its own brackets. Now, can I ever make a variable be a number and a number be a variable?
Yes.
The answer is no. Can I make a number be a number and a variable be a variable? Yes. But I can't make them be each other, correct? So I have to look at these separately. And I need to make a common denominator. If I had a common denominator, then I could, if I have a common denominator, what are you doing?
Found it's mine now.
You put the league hockey.
Okay, we have 3 and 5. What can I make them both be?
3 and 5.
15. So the only reason why we make these ones the same, is because they're numbers in their own bracket, right? They're not attached to something. It's not like x plus 5 and x minus 5, right? They're separate. So I'm going to multiply this one by 5. Please stop talking. And I'm going to multiply this one by 3. Then both denominators at the very least will be 15. We agree? So now we have the numbers the same. And I told you we can't make numbers be variables. Cody, stop. We can't make numbers be variables. And we can't make variables be numbers. We agree? So we made numbers be numbers. Now this one here has a y, and this one does not. So what are we going to have to do? Multiply it by y. Now, this is what we do when they're monomial. So they're not attached by plus or minus signs. When they're attached by plus or minus signs, we're going to handle it totally differently. But when they're both separate in their own brackets, we can make numbers be numbers and variables be variables. So on the top left, in the numerator, I'm going to get a 5 over 15y. And then on the bottom numerator, or the right numerator, I'm going to get 18y over 15y. Now, please pay attention, because this is where you're going to error every single time. I have literally drilled into your heads for a week and a half that we simplify the numerators and the denominators so we can cancel off, correct? I've drilled that. You have that, it's embedded. You could do it in your sleep at this point. What you need to not do is simplify now. You're just going to put yourself right back to where you were. So what are you going to do? You're going to go, oh, 18 to 15. I can take a 3 and a y out. And then you just literally back to the question you had. So you have to stop yourself in addition and subtraction from simplifying off what you just put on. Okay? It's hard. You will try and do it, and then you'll call me over and you'll be like, I can never get these to match. I'm like, yeah, because you keep taking it back off. Okay? So our first step is common denominator. Then right away, once we have a common denominator, we write it over one denominator. So it's going to be all over 15y. And we go 5 plus 18y. And then we collect like terms if we can. Is there any like terms on that top? No. We have a 5 and an 18y. Yeah, I feel like it's coming in our window. We're getting hit by an airplane. Okay, there's nothing I can do to this, correct? So, what I do at the very end, when I combine like terms, is I always say, can I simplify the top or the bottom anymore? Can I take anything out of the top? No. Can I take anything out of the bottom?
Yes.
No. So, all I do is I state my non-permissible values behind. What's my non-permissible value for this one? Y cannot equal 0. That's it. Sorry?
I was going to say, can't you take y, the y on the top of the y?
Nope, because the top is attached to the plus sign. Okay. We're going to look at the bottom left. The bottom left has a 6 and an x and a 3 and an x. So those are separate, correct? So, what can I do to make them the same? This one has an x and this one has an x, so that's good. Multiply the second one by 2. Now what we need to remember is to multiply the whole numerator by 2. So we're going to get 2x minus 5 over 6x minus 6x minus 4 over 6x. Now we have common denominators. Do we try and take out anything, or do we just go right up and write it over one denominator? We just write over one denominator, right? Common denominator, right over the one denominator.
Don't you make that negative?
Sorry?
Don't you make the 6x minus 1 negative?
Yeah, after. Yeah. So we're going to write it all over one denominator of 6x. Now we're going to go 2x minus 5, and then this is where I said the common error is going to hit. We have to remember to subtract the 6x, which everyone does, but you also have to remember to subtract the 4. All right. So we're going to get minus 6x plus 4. So you have to remember that when you're subtracting a binomial, that you subtract both those terms. Okay? Then what do we do next? Collect like terms. So we get 2x minus 4x, which is, sorry, I was giving the answer. 2x minus 6x, which is negative 4x. And then minus 5 plus 4, negative 1 over 6x. So after we collected our like terms, we do one last check. Can I simplify GCF, difference of squares at the top? Can I simplify GCF, difference of squares at the bottom? The answer is no. So I have to make sure I follow behind with x cannot equal what? 0. You are going to try D, please. And then we're moving on to ones where it's not monomial denominators. So we're going to look at D. We're going to look at D and we're going to pay attention. The denominator is a monomial and a monomial, right? There's no plus or minus signs in them. So they go in their own separate brackets. The top, or if I look at just the numbers, I have a 2 and a 5. What can I make them both be if I just look at the numbers? 10. So I have to multiply the first one by 5, and the second one by 2. Then I look at the letters. The one on the left has an a squared, the one on the right has an a. What do I need to do to make them match? Which side? The right. I'm actually going to multiply by 2a, not just 2. So I have to remember to distribute. This is where people mess up. They don't distribute. So I'm going to get 5a plus 35 over 10a squared minus 6a over 10a squared. Now I have one denominator, so I can write it all over 10a squared. And I have 5a plus 35 minus 35. You're going to want to watch yourself, because if you don't do this step in the middle, most often, especially if this isn't a monomial behind the subtraction sign, you're not going to remember to distribute, and then you're not going to collect them correctly, and you're going to get the wrong answer. So I always show the extra step. So 5a minus 6a is negative 1a plus 35, which is technically its own bracket, 10a squared. Do I need the 1 in front of the a?
Yeah.
Do I need the actual 1?
I mean, I was talking about the negative sign.
Yeah, you need the negative sign, but not the actual 1. And then a cannot equal what? 0. Because a squared is like having an a times an a. So, up until now, we've had monomial denominators. So we've had like 2x times 3, or 2x times 3x, right? The denominators were the bottom. 2x and 3x, not times. And 3x and 6, or something like that. We had to make them be the same. They were monomials, correct? This is the catch now. This one is a monomial on one side, because they're both in separate brackets, and a binomial on the other. You can never make a monomial be a binomial, and you can never make a binomial be a monomial. So when one denominator is a monomial and one denominator is a binomial, you have to multiply them by each other. That's it. So we have x minus 9 in the top, and I'm going to put it in brackets, so I know it's in brackets, and I have 2 and an x, plus 3x over x minus 4. So I'm going to have to multiply this one by x minus 4. And this one by 2x. Now you guys please pay attention here. If you're multiplying something that's not a monomial times a monomial, you never put the denominators together. So a monomial times a monomial, we multiplied them together and we gave like 10x squared or something like that, correct? But when it's not a monomial times a monomial, you'll just rewrite your denominator the way it is, and you actually distribute the top but not the bottom. Okay?
Is there a reason why you don't put the 3x that's in the right numerator, like separate?
Because if you put it separate, you're going to have to put it together anyways to multiply it.
Okay.
Yeah. So, on the bottom of this one on the left, I'm going to have 2x times x minus 4. So I leave the monomial by itself and I leave the binomial by itself. On this bottom right, I'm going to have 2x times x minus 4. I'm not going to distribute them together. So the only time for addition and subtraction, you might want to leave this for a little self-note. The only time I distribute the denominators in adding and subtracting is if they're both monomials. So the only time you distribute denominators or put them together is if they're both monomials. So no plus or minus signs. Are these both monomials? Nope. 2x is a monomial, x minus 4 is a binomial. So I don't put them together. I leave them separate like this the whole way along. Yeah?
If they're both binomials.
Same thing. You're going to leave them separate. So the only time you put them together is if they're both monomials.
And you still can't cancel them if they're binomials.
Right. Okay. So here's the catch. You're going to try and cross off the 2x over the 2x and the x minus 4 over the x minus 4. You just put them on. Do not cross them back off. That undoes what you just literally put on. So I'm going to never distribute the denominator unless they're both monomials, which these both are not. So I'm going to leave them separate. But I do have to distribute my numerators always. So I have to FOIL for this one, because it's binomial times a binomial. So I'm going to go x times x, which is x squared. So first times first, then outer times outer, negative 4x. Then inner times inner. Yeah. And then negative 9 times negative 4?
36.
Plus 36. Then plus, I'm going to distribute these ones. Now people, you guys, paying attention. 3x times 2x, people try and do as foiling. You can only FOIL if you have a number plus a number times a number plus a number or a number minus a number, correct? Do either of those have signs in them? No. So it's just 3x times 2x, which is 6x squared. Then I'm going to write the whole denominator. I'm not going to skip this middle step. And I'm going to go x squared minus 4x minus 9x plus 36 plus 6x squared.
There's so many extra steps there. Like, you could have skipped that whole step and just went right to what you're about to do here in a second.
So we have x squared plus 6x squared is 7x squared. Minus 4x minus 9x is minus 13x plus 36. And we don't have to factor that. We just have to follow behind with our NPVs. You actually can't factor this. X cannot equal what? 0 or positive 4.
As I mentioned 2 times.
Sure you were.
How love these.
So when it's a monomial on one denominator and a binomial on the other denominator, you have to multiply them by each other, and you don't put them together in the bottom, correct? The next one is a binomial and a binomial. Once again, you can't make them be each other. So you're going to have to multiply them by each other and not distribute them in the denominators, correct? The only time you put your denominator together is if they're both monomials, which they're not. So I have 2y plus 5 and y minus 3. Is there anything I could do to those to maybe make my denominators be the same? No. 2y plus 5, y minus 3, I can't take anything out of them. They're not a difference of squares. So the only thing I can do is multiply each side by each other. So I'm going to get 4 over 2y plus 5 minus 1 over y minus 3. I'm going to have to multiply the left side by y minus 3 and the right side by 2y plus 5. Do I distribute those denominators? Do I FOIL them together? No. The only time I'm going to put together my denominators is if they're both monomials, which they're not. So I'm literally just going to write them separately. But I will do my denominators, correct? So I'm going to get 4y minus 12 over y minus 3, 2y plus 5, minus 2y plus 5 over, don't put them together. It's going to be hard. You're going to have to resist putting them together. If you put them together, you're going to have to factor them and pull them apart back at the end. Now, I have the same denominator, so I can write them all over 1. Y minus 3, 2y plus 5. The top, I'm going to get 4y minus 12 minus 2y minus 5. Remember to distribute that minus sign through. Then we collect like terms. 4y minus 2y is 2y. Negative 12 minus 5 is negative 17 over y minus 3, 2y plus 5. I asked myself, can I simplify any of these? Cancel them off? That was my last step in addition subtraction. Can I do anything to that numerator? No. I do have to still do one thing though. State NPVs, my non-permissible values, or my restrictions. So one is going to be 3. Y cannot equal 3. What's the other one going to be?
Minus 5 over 2.
Minus 5 over 2. And if you can't remember how to do it, and you can't do it in your head, subtract the 5 over, divide by 2. And I would hazard you to show the work because I get tons of people writing 2 over 5. You just accidentally flip it in your head because you don't do the steps. No. G is for you to do.
Ooh.
Try it out.